it mechanics or kinematics?
Well, the whole chapter I call it mechanics.
Okay.
There's more mechanics in it than kinematics, I would say. Okay, equations of motion. Got that? Yeah. All right. Let's be precise now. Uniformly accelerated linear motion. What type of motion is that? So let's look at each word. Uniformly. What does that mean?
Constant.
Constant. Yeah. Accelerated.
Increasing in speed.
Yeah. Has an acceleration. Yeah. Linear. Straight what? Yeah, straight line then, yeah. And motion, obviously, movement. So when we say uniformly accelerated linear motion, that is motion which is one, in a straight line, that's the linear part, and has a constant acceleration. Yeah. Uniformly accelerated. And it is a very common problem in physics. Okay. Yeah. Got that? Yeah. Okay. What would the graph look like for this type of motion?
Sloping.
Yeah.
Upwards.
Yeah.
Straight line.
If it's accelerating upwards, you know, this is the time and this is the velocity. It should just look something like that. That's a uniformly accelerated linear motion graph. In fact, it's going to be the same, you know, that you did in maths, the y equals mx plus c. It's going to be a straight line like that. Now, before I start, we can make some equations. You mentioned the equations earlier. Technically speaking, the proof is required for the exam. However, I have about 35, 40 exams, and the proof has never been asked in the exam. But technically, it's on the syllabus, the proof. So they could ask you the proof in the exam of this, but they have not done that yet. But I still need to show you the proof because you could be asked it, could come up. You know, you could be the lucky ones, you could be the first class to do the proof in the exam. You never know. So let's have a look here at the formulas. Let's just, before we even look at the graph, I just want to make a, well, no, we'll start with the graph. Okay. So this one here is going to be U, this one here is going to be V. And we said from last class that the A is equal to the slope, which is going to be V minus U over T minus 0, which is V minus U over T. That's the A. We can rearrange that and we can end up with this result. V equals U plus AT. This is our first equation. Got that? Yeah. Okay. Next, second equation. We said last time that the area here, which I'll break it up as follows, represents the distance, the S. So we can say S equals the area, which will equal UT, which is that part, plus a half T by, and what's the height of this triangle? What's the height? V minus U for this height here, to get this one here. Yeah. So that will be UT plus a half T U plus a T minus U, because I can put that in there for V. So I get UT plus a half T times AT. So I get UT plus a half AT squared. And now I have my second formula. S equals UT plus a half AT squared. Yeah. Now, before I continue, I'll just remind you of this triangle, you know, the distance, speed, time triangle. So often we call the formula from this the zero formula, the one that says distance is equal to speed multiplied by time. Because it's such a basic formula, we call that the zero formula. But let me just clean this up a little bit. What letter represents distance? S. Now the problem is we have two speeds. The speed changes, and maybe you remember what I said to do last time.
Average.
Average, yeah. So that would be U plus V over 2T. This is called formula zero. Okay, so one formula left. What I'm going to do is to use one. I can say T equals V minus U over A, and then put this into zero. So if I put this into zero, so this in here, yeah, I can get S equals U plus V over 2 times V minus U over A, which is all over 2A UV minus U squared plus V squared minus UV. So I get S equals V squared minus U squared over 2A. So finally I get V squared equals U squared plus 2AS. Formula 3. Yep, there you go. More? Okay. Can you still read? Yeah.
The S equals to U of V over 2. The average is due to
Say again?
Is it what's it for an average?
Yeah, you see that formula, distance equals speed multiplied by time? That only works if the speed is constant. So what do you do if the speed changes? Well, you use the average speed. This is usually acceptable in physics formulas. If the formula requires a thing to be constant and the thing you have changes, then you can just use the average.
So you put 1 into 0.
Basically put 1 into 0, yeah. So it's not a horrible proof, but, it's still a lot to do, especially if you don't know how to do it. Yeah. So we now have 4 equations, or 3 equations, depending on how you count it. So if we think about this as U, V, A, T, S, each equation has always, you can see, at least, I think, 4 in it. Yeah, so it means that you must also be given 3 of these before you can solve. Yeah. Let's continue now. These proofs could be on the exam. Alright, so to summarize, we have this one, which you wrote, this one, and this one. I think you have all these written down. Yeah? You got these? To solve any of these problems, we need to know at least 3 of the 5 UVATS. These problems are often called SUVAT problems. SUVAT. However, my teacher always called it UVATS problems, which I think I cannot get out of the habit of saying. I would like to call it SUVAT, but I'm afraid I always say UVATS, which is much longer. So these are UVATS problems, but I do prefer calling them SUVAT. It's much nicer to say as one word than 5 words. Anyways, I'm only telling you this because maybe if you're watching a YouTube video or a lesson or something like this, you might see these called SUVAT problems.
Why do we call them Carnot?
Yes, my American friend, you can call them this if you like. I think over in at least in Ireland anyways, we call them by the letters. Okay. You can say SUVAT, or they're also known as kinematic equations of motion, as you said. Okay, so here is our first example. Not too crazy. A girl is about to start cycling her bicycle. She's at rest and cycles to 9 meters per second in a time of 6 seconds. Okay, before we start, what are the things we know? What letters do we know?
Initial.
Yeah, so which letter is that now?
U.
Yeah, we know the U. What's the U?
0.
Okay, do we know the V?
Yeah, 9.
We do know the V. Okay, do we know the A?
No.
No. Do we know the T?
No.
We know the T, yeah. And then do we know the F? No. What do we want? How far did she cycle, so what do we want?
F.
Yes. So which formula should I use here?
S equals U plus V over 2T.
Yes, I think I could do that. S equals U plus V over 2T will do nicely. So S equals 0 plus 9 over 2 times 6, which is 27, I think. Yeah. Okay, that's part 1. Part 2 would be, of course, to get the A. What would be the best way to get the A? What formula could I use? Yeah, I could use the definition, but which formula could I use? Which one is like that? Yeah, I could say V equals U plus AT, which is A times 6. So I'll get here A equals 1.5 meters per second squared when I solve this. Okay, that was an easy example to start with. Are we all okay with that? Yeah. Alright, let's see the next one now. Alright. I'll let you try it first just before I do it. It's not much more difficult, except there is one small problem. A car is travelling at 120 kilometers per hour. The driver sees a crash up ahead and suddenly brakes. According to the RSA, it will take 100 meters to bring the car to rest. What is the acceleration? Okay, so what's the first problem with this?
0 meters per
Yeah, you'll need to convert that into meters per second. So I'll give you a minute. I want you to try the A and the B part. What is the acceleration and what is the time? How are we doing now? Do we have the first part done or? Okay, you should be nearly finished now. Finished? Oh. Nobody's finished yet, I don't think. Got this? No? Think so. Let's have a look. So the first thing I want to do is get that into meters per second. So let me see. 120 kilometers, so kilometers per hour, per 3,600 seconds. So this is my U. My U is 33.33 meters per second. My V I definitely know. What's the V? Zero. The A I don't know. I suppose the only thing I know about the A is that it should be negative. The T I don't know, and the S I do know. It's 100 meters. Okay, so let me see, what do I want first? I would like the A, so what could I use? B squared?
Yeah, I
b squared equals u squared plus 2as. So the a is minus 33.33 squared over 200. Okay. Looking good. Yeah, all the fives. Minus 5.56 meters per second squared. And now the t, what would be the best way to get the t? I think perhaps v equals u plus a t. So the t would be the 33.33 over the 5.56. Okay, let's see. 6 seconds about, yeah. Okay, that wasn't too bad. I hope you got that. Continue. Okay, here's another one for you to try. A ball is dropped from the top of a building. The building is 25 meters high and it takes 2.26 seconds for the ball to hit the ground. What was the acceleration of the ball? And then how fast did it hit the ground? Well, we'll have a look now. You have an answer? Yep. And you have an answer? Yeah. And what about over here, you two? Got an answer? But you're not sure? Okay. Let's just draw the picture here. The ball starts here and finishes here. Now there's a couple of ways to do this, but what I wanted to teach you with this example is it is useful to take care with the signs. Let me give you an example. What's the u here? 0. Yeah, which it is 0, isn't it? Or yeah, I tell you this in the question. The v, we don't know. The a, we don't know. The t, and the s. Yeah, now this is where I feel it's useful to maybe say it's minus 25. If I consider this to be the start, and if I take up to be positive, then net down should be negative. If you didn't do this, it's okay. It just means you're taken down as positive, which is okay. It's okay. Right, what did I want first? I wanted the a. So what could I use? S equals? S equals ut plus a half a t squared. So the a will be minus 50 over 2.26 squared. Yep. Okie dokie. 9.79. And then the second part is I want the V. Well, I'll just say V. No, don't worry. Everything is okay. I assume. Just step over the body when you get down to the ground floor. Right. V equals U plus A T. Now, it's actually nice because this answer here will have the minus in it. It kind of makes sense that it has the minus because it's heading down into the ground. Minus 22.1 meters per second. Yeah. Okay, happy with that? Yeah. Oh, sorry, you need a second there, yeah? Getting too cold? Need the windows closed now? How about you guys? Windows open or closed?
Or do you guys want to partially?
Maybe we'll close one of the windows, I think.
Either one?
Let's see, which one's colder? I think, no, I'd say they're both equal, so either one, yeah. Air conditioning. Yeah. Okay. So, interestingly, this last example kind of shows us something when things are dropped. So here's somebody dropping a ball, and at the beginning it's going 0. Then after 1 second it's traveling at 10 meters per second. Then after 2 seconds it's traveling at 20, and then 30, and then 40. So each second it's getting 10 meters per second faster. So the acceleration is 10 meters per second squared. When a ball is dropped, its speed will increase roughly by 10 meters per second each second. So that's 10 meters per second squared. It's not exactly 10, and you probably all know the exact value. This is called the acceleration due to gravity. And on the surface of the Earth, we use the letter G to represent the acceleration due to gravity. And it has a value of about 10. The G is about 9.81 meters per second squared. This is if you're near the ground. In fact, if you are very high up, like on the very top of a mountain, the G is actually a little bit smaller than this.
So, which one do we use normally? 10 or?
We usually use 9.81. It's just the picture there. It's just easier to look at if they're in tens.
So in vector questions, we don't use 10, we use
9.81, yeah. What did you use in high school?
10.
Really?
I used 9.81.
That's much better. Although, can you use a calculator in your exam?
Yeah.
Oh, you can? And they still made it 10? Right. Usually in some exams where they don't let you use a calculator, they make it 10. Interesting.
So our final one, will we be able to use them?
Oh, of course, yeah.
Math or math?
Yes.
And you can do it, right?
Yeah, well, there's some limitations. Like, for example, the calculator can't have a dictionary in it. I think there's 3 rules. The calculator can't have a dictionary. It can't have Wi-Fi to connect to the internet. I don't know why your calculator would. The calculator can't connect to other calculators. So so you know, don't message somebody in the exam. And the calculator can't be able to do algebra. And what I mean is, it can't be able to, you know, manipulate and show you the steps.
How about drawing graph?
Yeah, but you can have a graphing calculator.
That's the only thing the best thing I got from American system is this calculator.
The Americans love their graphing calculators. They love graphing calculators. Like, every time I have a student that was American educated, it's like, they all come to school with their graphing calculator.
The first thing that went to my suitcase was my graph.
That's it, yeah. Yeah.
What about the calculator that has when you integrate something,
Yeah, I can use that. Yeah. The calculator I recommend, because I feel it's a good balance between function and simplicity, is this one here. It has lots. Yeah, that one there. It has. It's quite powerful because it can integrate and do things like this. But it's not as difficult to use as a graphing calculator.
This calculator is hard because
yeah, it's ugly.
the fraction is...
Yeah. Now, if at some point... And the other thing I like about this calculator is that it has all the physics constants. So, yeah, you can, for example, what constants have you done in chemistry yet? Have you done any constants yet? No. Well, like for example, Avogadro's number, which you might know from chemistry, is on the calculator. It's number 24. You know.
But are we able to bring the cover in?
Oh yes. Yeah, a lot of places don't let you bring the cover in, but you can. So, you know, are you happy enough using that calculator? Does it have any physics constants built into it? Do you know?
No, but I can sort it.
Oh, you can? Okay, good, alright.
Imagine
This is the standard Malaysian calculator, is it?
I
Yeah, okay.
study in a British curriculum. I shifted from this to this.
Step up, yeah.
That one's way better.
It's a nice balance between everything, yeah. Okay, this is the value of A when something is fallen to earth, or when you drop the ball, for example. So you really just need the value. Okay, you got that? Yeah. Right. Here is one now. So this is more. The last questions were a little easy. Now we're getting to exam difficulty. Okay, so this would be more like an exam question. And for this question, you can use the value of G, 9.81, that I just gave you. So a ball is thrown upwards at a speed of 50, and the ball leaves the girl's hand at a height of 1 meter above the ground. So just to make sure you're clear on the picture here, this is the ground here, this is the girl here, and this is the ball here, and it starts at 1 meter, and then she throws it up. It goes up, and of course comes back down like that. And the speed at the beginning is going up at 50 meters per second. And then the ball falls back down, and the girl does not catch the ball. She lets it hit the ground. And the first question is, what is the maximum height of the ball? So by that I mean, how high up will it climb? So I'll start it, but I'll let you continue. But just to get you started, UVATS. What's the U for this problem?
0.
The U is 0? I do not think so.
Oh, is it 50 years?
It's 50. The U.
Oh.
The U, yes. The V
0.
is 0. Now, why are we saying the V is 0 though?
It lands on the ground.
Oh, no. We're looking here. Yeah. The V is 0 because it will increase, stop, and then come back down. Yeah. The A?
9.81.
Is it? You were closer with 9.81.
Oh, what?
No, you must have the minus because we say down is minus, up is plus, and it's the accelerations to the earth. That's important. The T we don't know, and the S is what we really want to know. Okay, calculate the maximum height. Okay, so I'll just flick back here. So I want you to try these parts here. See how you can do. So first one is the maximum height.
Wait, she chose it at 15 meters a second.
Wonder Woman.
Wait.
All of the question.
Yeah, yeah. You got the maximum height? Yep.
There's no time limit.
Yeah, yeah. That'd be a very easy question if I gave you the time and asked you for it. Okay, how are we doing here? Which part are we on? Okay, that's okay. Over here, how are you two doing? You're on C, okay? B, okay? Got that?
The time. It does not feel.
Looks hard, huh?
I think the one I calculated is just the one that goes up to the maximum height, but then the return one.
Yeah. Let's have a look. Okay, let's have a look. Let's do this one together. So the first one, what formula to give us the S? It's just going to be S equals UT, isn't it? U. But you know what? I'll just put it on my calculator. U. No, we don't know the T. So what will we have to use? V squared. Okay. V squared equals U squared plus 2AS. So, what's the answer here? No, gotcha. Gotcha. If you said 127, I gotcha. It's not 127. It's 128.
1 meter.
What? Oh.
If you trade from 1 meter.
Yeah, that 127 is from here. This is the start. That number you just got was this. I gotcha bad. Alright, good. 128. B, which caused you a lot of trouble. How to do B? Any ideas?
Use a formula that doesn't have C.
That
doesn't have S.
That doesn't have S in it. Ah! Which formula is that now?
B equals UA plus C.
Well, what's the question B again?
B is total time. How long until it hits the ground? Okay, so let's see what we know. Do we know the U? Yes. Do we know the V?
Yes.
Do we?
Oh no.
I mean, if we do, what is it?
Zero.
The ball is not going zero when it hits the ground.
I mean, like just before it reaches the ground. Then it's another calculation.
Yeah, so we don't know the V, do we?
Oh yeah.
No. The A we know.
9.8%. 1.
Yes. Yeah. The T
No.
we don't know right now, and the S.
We don't have the right. Yeah, we know what half of it.
What? Yeah. What would you say the S is?
8 times 2.
8 times 2?
No,
No.
1 to 8 times
128 times 2. Are you sure?
-1.
Minus 1.
Wait. Yeah.
Yeah.
But
Because it's 127, and then when it goes down, it's 128.
Yeah.
yeah.
You agree or disagree?
So then
Because you threw it from 1
Yeah,
meter
yeah,
above
I
the
know.
ground, and then that's 127 to reach the top, and from top to the ground will be 128.
You agree?
2. Yeah, that's the distance.
Yeah.
Yeah. So that's
No. You see, don't listen to this guy. He thinks he's great, but you suspect something's not quite right. So tell me what you're thinking. Yeah.
Yeah?
Yeah. So what is the S? Do you think?
1 to 8.
Oh no! I thought you were going to say it. No, you're agreeing with him, kind of. No. It's not 127. It's not 128. It's not 127 plus 128.
okay.
It is. No, it's not 1.
Negative.
Wait.
-1.
What do you think? Yeah, go on.
Negative 1 to 8.
No, not this either.
-1.
It's -1.
Well,
Why?
because it's going down.
But it reaches up. Let's go.
Yeah, but what does the S represent? You just said it, displacement. It is 1 meter below where it started. Ah, it's so clear now. Yes, you got it? So this is a very, very common mistake in the exam. It's like one of the most common mistakes students can make in the exam. Everybody goes, oh, I know the S, it's 127 plus 128, and everybody gets it wrong. So please, be careful with this. It's minus 1. So, we can use our formula. S equals ut plus a half a t squared. Or, we can rewrite this as 4.905 t squared minus 50t minus 1 equals 0. What type of maths problem is this? Quadratic. Now you probably, oh well no, have you done this with your maths teacher yet?
Yes.
Yeah? Have you done the formula? No, factorize, is it? Yeah, well, we can't factorize this because of the 4.905, it's a bit hard. So we can use the formula, or if we're feeling really lazy, we can use the calculator. Mod 53. A is that? B is that? T is that? Now, don't worry, you will learn how to solve these in maths class this week probably, okay? But for the moment I'll just use the calculator. The first answer seems fine, 10.2 seconds, and the second answer does not make sense. So 10.2 seconds is the T. Yeah. Okay, C. Yeah?
Why is it negative 1 again?
Yeah, does it?
Not positive 1.
Oh, because we say up is plus and down is minus. So it is 1 meter under where it started.
Also you have to like make the point, the hand at the point.
Yeah, this is like the origin. And everything that is above it is a plus and below it is a minus.
The same goes with velocity.
Yeah, and acceleration. Yeah. Okay, C. How far does the ball travel? Well, that's the distance. And that is 127.4 plus 127.4 plus 1. That's that one. 127.4 plus 127.4 minus, no, plus 1.
Plus 1.
Yeah. 255.8 meters. And finally, D. Oh no, not D. How fast is the ball going when it hits the ground? Well, that's just V equals U plus AT, which is 50 minus 9.81 times 10.2. And why is it a minus? Going down, yeah. Okay, and E. What was the average speed? What's the formula for this? Yeah, what is it? Yeah, total distance over time, yeah. Now, just to be careful, you might think, oh wait, hang on, didn't Stephen say a few minutes ago it's U plus V over 2? So just maybe to go to the side for a moment, just to be very clear about this, to be very, very precise, okay, the average velocity is U plus V over 2. Because this is the initial velocity and this is the final velocity, so the average velocity is U plus V over 2. But the average speed, if we're being precise, is not this. It's actually the distance over the time. That's all. If we're being precise here. So, back to this one, the average speed is the distance over the time. Uh, 25.1 roughly meters per second. Yeah? How did you do it?
I split it with 2 parts.
Yeah?
So, like 2 super.
Aha.
So went from my here, like when you throw it
Oh, yeah.
to the top highest point, and another part is from the highest to the lowest.
Ah, you did it this way, for the whole thing? Yeah, yeah. There's always a few students every year who like to do it this way. If you like to do it a longer way, that's fine.
How I learned it.
Yeah, no, I know. It's one of those things where a lot of physics teachers would tell the students to go from the bottom to the top, and then the top to the bottom. But if you're careful, you can go from the start straight to the end by using the -1. You know, so in other words, I've taken a shortcut, which is what I would expect the students to do in the exam to save time. But your answer is fine too. Okay, you have that? Yeah? Right, let's see now. I don't think there's any more examples. Okay. How many questions are on the next worksheet now that I give you? Okay. Do they look hard? I'm sure they're hard. Let's see. They're okay. 1 to 6 is easy. 7 is interesting. I'll let you try these for a few minutes, and then whatever you don't finish, I want you to finish at home for homework, and then we'll go on to the next lesson in a few minutes, okay? I think you would probably prefer not to take a break and finish a bit early, rather than to take a break now and finish in an hour.
We have 2 classes.
I think we do.
It's 2 hours.
Oh, this is
Yeah.
a shock to you.
No,
Is it?
because one time we have one sister, I was mad, I was like, oh, this is not nice.
Sure. I believe you.
Oh, it's on Wednesday.
Oh, Wednesday's one. Okay. So I think if you try these for 5 minutes, and then we'll start the next lesson and we'll finish at 4:40. Yeah.
Questions regarding the.
Yeah. Oh, yeah. What I want to do is I don't have the timetable, but whatever the last physics class of the week is, I'll make this class a tutorial where we'll answer whatever questions you've built up from the workbook. So just make sure you circle it to ask me in the tutorial.
Okay.
Yeah, so just mark it in your book and remember to ask me. I'll be back in a second. Try these for 5 minutes, please.